Okay, guys, so today we are going to learn about pointers and arrays. So this is the next topic that comes to our previous videos. Okay, so what is an array? An array is a contiguous memory location, right? For example, if I say int a5, this declares an array of size 5. And what does that mean? So instead of reserving space in memory for one integer, uh, five memory locations are stored, are created, and they all are contiguous. Okay, so by contiguous, what I mean is, for example, suppose this one, let's say the size of an int is 4 bytes on my machine. This is a common thing on most of the machines. Like you'll find integer as 4 bytes. So assuming this, what does that mean to have contiguous memory location? So for example, let's say this memory location is 2000, then this one would be 2004, this one would be 2008, this one would be 2012, and 2016, right? So all the five blocks for integer are stored contiguously in memory. Um, so this is what an array is. Now, how a pointer is related to an array? That is the question, right? Um, so to understand that, uh, we have to know what does this array name signify. Okay, so in the previous example, like what is a? A is a constant pointer, constant integer pointer, we can say. Now, what do I mean by that? I'm saying integer pointer, right? So it's something like int star, but it's also constant. Okay, so if this is true, then I should be able to do something like this, right? This should be true, right? Um, and and it's constant. So we cannot do operations like a plus plus or a plus equal to 2, a minus equals 1, something like that. All these are not permitted. But this ptr variable, ptr is not constant, right? So we can do things like ptr plus plus, ptr plus equals to, like that, and so on. Now you must have noticed that we are doing arithmetic operations on pointer variables, right? Can we do that? And what arithmetic operations are allowed on a pointer? Arithmetic operations. So we can do. So here's the thing. Uh, we can add an integer to pointer. Okay. We can subtract an integer to pointer. Uh, what else we can do? We we can subtract two pointers, but we cannot add two pointers. Okay, and we definitely cannot multiply two pointers. Okay, and we cannot divide two pointers. Okay, so let's call it 1, 2, 3, 4, 5 and 6. Okay. Um, Now what happens? So case 1, right? Adding an integer to a pointer. This one. What happens? This case. I'm talking about this case. What happens when we add an integer to a pointer? So let's say there is an integer pointer p, and it contains some memory location, address of some memory location. So let's say I have created a variable previously int a10, and then I'm saying that address of a is stored in p. Let's say a is at location 1000. Okay, it can contain any value, let's say 10, and then I have my pointer which is at location 1500, for example, and this contains the address of a. So I'm by that I mean this would contain 1000, right? This is essentially pointing to this location. This is a, this is p. Okay. Now let's say I'm doing p is equal to p plus 1. What this would do? So how this works is, this would advance the pointer to the, this would add a number to the pointer based on the type, what type of pointer it is. So for example, this is an integer pointer, right? So an integer size of int pointer is, size of int, not integer pointer, size of integer is 4 bytes. So this would advance to, this would add 4 basically. So p would become 1004, that is 1004. Okay. If I add 2, p plus 2, p equals p plus 2, this would do 1000 plus 2 into 4. This would store the value of 1008 to p. And this is true for any type of pointer, right? So let's say we have a char pointer cptr, and whatever address it contains, let's say this contains 2000, for example. So when 2000 could be, we can assume that at 2000 location there is a character. So cptr, this contains the address 2000. Let's say this is at 5000 location. Okay. When I do cptr equals cptr plus 1, what would happen? So going by the same rule, the type of cptr is char. So, and size of is 1 byte. So this would advance the pointer by 1 location. So the new value would be 2000 plus 1, and this would be equal to 2001. So that's how this would work. And this is true for any type of pointer. Okay. So if we have looked carefully in these two examples, uh, there is a common pattern of how pointers are incremented, right? So what is that pattern? So if you see, this is this thing here. If I'm adding 2, then this gets incremented by, so size of the type of pointer is multiplied by 2, and then that much amount is added to whatever value the pointer contains, right? So we can say that p plus n is equal to, I'm trying to give a general formula, uh, p plus size of type of p, type of P multiplied by N. So this is a general formula. So we'll apply that and see. So that's how this works. Now, what is the use of it? Why is this information, like, where could it be helpful? So now going back to our array, this was our array, 1000, then 1004, 8, 1016. This is A. So, and this was declared like this: int A 5 equals some number 10, 20, 11, 4, 6. So this would be stored as like this: 10, 20, 11, 4, 6, right? Now let's say I'm doing this star P equals A. So as I said above, the array name is equivalent to a constant integer point, a constant pointer, basically, or whatever type that array is, right? A is a constant integer pointer in our case because array was of type integer. Okay, so if this is true, then this is a valid assignment. This works because A is of type int star. Okay, and A is a constant pointer. Okay, so we cannot do A plus plus, right? But we can do P plus plus, right? So we can use this information to iterate the array, right? So we can say that we can P to iterate the array. That's one of the use. Okay, so now if I, so going back from here, now if I do P plus 1, so what does P contains at this time? P contains 1000, the base address of the array. Yeah, it's also worth mentioning that array name, we said that the name of the array is a pointer, a constant pointer, right? But what memory location it contains? It contains the base address of the array. So when I'm doing int p star p equals a, this would assign the base address to p, which is 1000 in this case. Okay, and now when I do p plus 1, this would be 1000, and then going by our formula or whatever we learned, size p is of type int. P is an integer pointer, so size of int is 4, so it would do 4 into 1, which would be equal to 1004, and P would move to 1004, which is the next location in the array, right? So we can, so you can see, like, we can use this to kind of iterate through the array. Another thing, how we access array elements like A0, A1, right? How does this work? How does this work? If I try to write this, now we know that A is some kind of pointer, right? So how we can, and if A0 gives us the value, can we say that A0 is translated internally to something like this? A plus 0, something like this, right? For now, let's take this. So similarly, A1 would be translated as A plus 1, but this doesn't translate to like just A plus 1. This would be multiplied by size of int. Okay. Um, so what happens? What happens now? A, we knew like it contained the base address, right? So A, if we go by this example, A base address was 1000, right? So this one would give me 1000, and then 1 multiplied by size of int would give me 4. So this is 1004. So, and let's do star 1004. Okay. So value at 1004 essentially. And you can see value at 1004 is 20. So this one would give me 20, right? Which is same as what we get through A1, right? So yeah, so we can say that, and this holds for all the indexes, right? This is a common pattern. Uh, Now, can we say A of I is equal to star A plus I? Yes, right? Right. Because when we add an integer, this one is like by the rule of like how integers are added to a pointer, they would be multiplied by the size of the data type of the pointer, and similar to this one, and then this one works, right? Uh, okay. So next step would be like something like this: a plus I into uh, size of type of it, which is integer in our case. Or if we talk about like, it could be anything. Like if it's a float array, then it would be size of float. If it's a double array, it would be size of double. Uh, and then if it's a char array, it would be size of char. Okay. All right. Uh, so can I write this statement is equal to star I plus A as well, right? There's no difference, right? Because we are just adding an integer to a pointer, right? So, and does that mean this is equal to IA? This is something for us to try, right? So we'll try this out on the code, on the system. All right. But we can say that AI is equal to star of A plus I, which is equal to star of I plus A, and it should be equal to I. Okay, so we'll see if this holds true or not. All right. Yeah. Uh, so moving to the next, like continuing with on the same topic of pointers and arrays, how we can pass array elements as arguments. We can just we cannot pass all the elements contained in the array separately, right? There's no way to do that. But what we can do is we can pass the base address. Okay, so to pass the array as an argument, we can pass the base address. And then based on that, we know like when we increment the address by 1, it would move to the next location and so on, right? So that's how we'll access the entire array in a program. Uh, let's see how that works. So let's say I have a function. Okay, let's say I have this fun int star. This contains ptr, And then it also takes a second argument n, which is the size. We'll see why this is required. And this, let's say this does nothing. This just says for int I equals 0, I less than n, plus I. What we are going to do is printf %d and say new line for readability. If you want to like just copy the exact code, then ptr star ptr plus I. Okay, so we are doing this, and we are expecting that this would print the entire array. How this one would be called? So if the array is a, let's say I have this array again, a of size 5, which contains these values 1, 2, 3, 4, 5, right? I want to print. What I would do is I would call fun, and as I said, we have to just pass the base address, and then we know from there on, if we add 1, we would be able to move to next location, so on. So and what contains the base address? The array name. The array name contains the base address, right? So in our case, it's just a. And then n is the size of the array. In this case, this is 5. What would happen when we do this? So let's say our array is, again, we draw this, and then this contains 1, 2, 3, 4, 5 as value. This is array a. Let's say this is at location 1000, then 1004, 8, 1012, 1016. Okay, now I'm passing this in fun. So a contains 1000, right? A is pointing to this base address, which is 1000 in our case. When we pass this value, this is received in this PTR, right? So PTR is at some memory location, let's say 2000, and 1000 value is copied into PTR as an argument, and n equals 5. Okay, now let's see the code. So what do I mean by like when PTR contains 1000? This essentially means that this is pointing to this location, right? Now let's take a look at the code. For I equals, let's try to dry run this one. Okay, so I would go from 0 to n. I would go from 0 to n, and then we are just printing star ptr plus I. Okay, so let's take this code here. Okay, so for the first time I would be 0, and then we are printing. To print this, we would go inside the loop here. We want to print, so we would do star of ptr plus I, right? So ptr is 1000, so this would be translated into star of 1000 plus 0, which is star of 1000. Now we learned that this is dereferencing, so we can call value at operator as well. So value at 1000 is 1, so it would print 1. Okay, now what happens? After this line is executed, the loop goes on plus I. So I is 1 now. Okay, and then this condition is checked. So I is less than n. You can see n is 5. So 1 is less than 5, which is true. Again, we are going to print star ptr plus I, right? So what would that convert into? Star 1000, ptr is still 1000, right? Plus I is 1, right? Now, how this would be working internally, we know, right? So this one would be converted to 1000 plus 1 multiplied by size of the type of PTR, right? The type of value that this pointer is pointing to. Okay, so what is that? PTR is an int pointer, integer pointer, right? And see, PTR is an integer pointer. So this would be size of int, and which is nothing but 4, right? So this one would be 1004, and then we are doing star of it, right? And what is that 1004? 2, right? So this would print 2. Okay, and so on. Again, in the next iteration I would be 2, and this one would convert in. So we just printed 2. Next iteration I is 2. So again we would do star of 1000 plus 2, which would again take the data type, multiply it by the size of it, and it would internally be 2 into 4, which is value at 1008. We'll go and see what is at 1008. This is 3, right? So it would print 3. So this is how it works. Okay. Now there could be one more way for us to print it, right? Because you can notice that we are not incrementing this PTR, the value that this PTR contains at all, right? It still points to the base location. We don't need to. But PTR can be incremented because it is not a constant integer pointer. It's not the name of the array. It's a normal integer pointer. You can see here, right? A is our array name. So this is A is constant integer pointer. It cannot be increased, but PTR could be. So what could be the other logic? Let's see. We can also write something like this. Let me think. Okay, so we can say for int I equals 0, I less than n plus plus I, and then we can say printf %d, say star ptr, and then this, what we can do is we can say plus plus star ptr. Okay, so this should also work, right? We'll see how. Let's draw our boxes and see how this works. So we can try something like this, right? But there is one problem here, and I would like you guys to kind of think about it, what the problem is. Like, I want you guys to draw the blocks and see. But anyways, I'm going to do it here. I'm going to explain what the problem is with this approach. So in this case, again, our array is A. We are taking the same previous array. Okay, so it was 1000 location, and 1004, 8. Okay, this 1, 2, 3, 4, 5. We have passed the base address to A, to PTR. So PTR is at 2000 and contains 1000. Now try run this one. I is 0, right? I is 0 for the person. Printf star PTR. So star PTR, PTR is pointing to this location, so this would just print 1, right? So 1 gets printed. What happens next? Plus plus star PTR. Oh, so here there's a little bit mistake. We don't have to do this star. So it's just star PTR, okay? So what would happen? As I said, like we can increment, and the next value would be according to the type of PTR, which is integer. So you guys can do the calculation, but this would be 1004. Okay, so here this one would be replaced by location of 1004, right? So this one does not hold now. This points to this location. Okay, so this this statement was executed. Now the loop goes back here. I is incremented to 1, and then I is less than 5, 1 is less than 5, which is true. So we again come back to this line. Again, star PTR. So star PTR this time is 2, right? And again, we are incrementing plus plus PTR. So this one would be right now 1008. And essentially this does not hold true. This one is now pointing to this location. I becomes 2. Now 2 is less than 5, which is true. And then 1008, when we do star PTR, we print 3, right? Next, we go to the next iteration. So after printing, again we are doing plus plus PTR. So this is 1012 now. So this is essentially now pointing to this location, right? And then we go up, plus plus I. So I is 3. 3 is less than 5, right? Which is true in our case. We again come to this statement, star PTR, again star PTR. What happens? 1004, right? And then again plus plus PTR. Plus plus PTR would take me to 1016, which is now this location, right? And then again I gets incremented to 4, right? Yeah. Now what happens? In this case now, there is some issue, but we'll see. I is 4. We go here. We print it star PTR. It prints 5, but then it gets incremented. It gets incremented by 4 to 20. But what is here? Right? We don't know. We don't know. So now this depends on compiler to compiler whether you'll get a runtime error here or not, because here what happens is PTR is pointing to a location which does not belong to this program, right? It's an illegal location for PTR to go there. But again, this depends on compiler to compiler. I think this should work in Turbo C, but in GNU compilers like GCC, this won't work. This would throw a runtime segmentation fault, essentially. Okay. Now, next topic is, okay, so let's try to visit what operations are allowed. We listed down like some operations which are allowed and not allowed, right? So we have seen we can add, we saw this, we can add an integer to pointer. We didn't see this one, subtraction. Okay, subtracting two pointers. Okay, and these three are not allowed. These bottom three are not allowed. So what would happen if we subtract an integer? Okay, so similarly, subtraction is same as addition. The logic is same. Okay, instead of just adding, moving to the next location, it moves to the previous location. So if I do ptr minus 1, and assuming that ptr is an integer pointer, ptr, and let's say this is 2000 location, it contains a value of 1000. When I do ptr minus 1, this would again do the same thing for me, like this would decrease it by 4, right? Why 4? Because ptr was of type integer. Okay, that's what it is. So subtraction is very, very similar to addition in terms of how it works internally. Okay, and now subtracting two pointers. Okay, okay, let's say we have two pointers. Okay, so int p1, and then we have p2. Okay, and we did some assignments, and currently p1, p2, let's say p1 contains 1000 and p2 contains 1012. Okay, what would happen? What would be the result of it if I do p2 minus p1? Would this be 12? No. So this, why it's not 12 is like, it's very similar to how a number is added to a pointer. So when we saw previously, right, when we do 1000 plus 3, this does not, this is not equal to 1003, right? This is not equal to 1003. There is some conversion internally. It takes the type that pointer points to. So if it, and then it multiplies it by that number. In this case, like our pointer was of integer type, so it multiplied it with 4. So similarly, if you talk about subtracting two pointers, similar thing happens. You cannot subtract, I think, two pointers of different sizes, but this we can try. Can we subtract of different sizes, different types? This we can try, but subtracting the same type of pointer, p2 minus p1, would give us the number of memory locations of that type. Okay, so what it would do, you can simply think of it like this. So we got 12, so p2 minus p1 would give me 12, but then this one is divided by the size of type of pointer. Okay, so in this case, if p1 and p2 are integer pointers, so this is divided, and size of integer is 4, so this is divided by 4, which is equal to 3. Yes. So this one would give me 3.